Hi, and welcome to another Hopper video. Haven't had one in a while, but I've just done a major refresh. Included in this refresh is a development environment that runs on Linux for the first time. First class development environment. It's got the full Hopper editor and debugger and all that. And I've updated the UF2 files to the latest version of the library, which I haven't done in about 6 months. Anyway, I'm going to do a quick walkthrough of how you get this up and running on Linux. I'm more of a Windows guy, as you probably realize if you've watched any of these videos, but I'm not evangelical about it. I don't really care which platform you prefer. To make it easier to record video, I'm using WSL on Windows, and I've got a Ubuntu machine set up and ready to go. So I'll show you how to install it on here. And for this purpose, I'm just going to assume I'm doing this on Windows. If you're a Linux guru, you won't do it this way. You'll just follow through the same steps, but you'll download directly, for example. So for this demo, we're going to need the Linux runtime, which is this. So we'll download that. Downloading. We're going to need, as usual, the full Hopper tree, which is the Hopper environment, all the source code, all the tools in Hopper. So we'll get that. And then I've got a Raspberry Pi Pico W2 that we're going to use for this demo. So we're going to download Pico 2W, which is this one, the ARM version, not the RISC version. Okay. And now I'm going to quickly copy those all to my desktop. Let me do that. Let me pause the video and do that quickly. Okay, so they're on my desktop now. Here they are. And if you've used WSL on Windows before, you'll know that you can use this path to get to your Linux drive from your Windows desktop. So I'm looking at home and my user is Michael. And what we want in here is we want this whole Hopper environment, which is the entire file. It's about 1,000 files. So we're going to take that and just drag and drop it from the zip file onto our Linux machine. And I'm going to pause the video while this goes on because it takes a little while. Okay, we've got our entire tree. So we've got 1,700 files in that tree, and it's all been copied across. So that tree over here is cd hopper, and I'm going to go to the bin folder. So if we look in the bin folder, that's what's in the bin folder. Right, now in addition, we want to put the Linux runtime in there, and it's the x64 Linux, which is the Intel version. I'm going to test an ARM version on a Raspberry Pi, and I'm going to build runtimes for Mac, both ARM and Intel as well. But for now, we'll just take this Intel version, and we could put it anywhere in the Hopper tree because it'll find it. So you can make a folder for it if you want to, but I'm just going to drop it in the bin folder. So those 3 files into the bin folder. Okay, now we switch to our Hopper screen. Now Ubuntu screen. All we've got to do is we've got to give it executable permissions, and then we can just launch it from here. And just like that, we have the Hopper shell running under Ubuntu. So we could go to samples. Oh, let me just do this quickly. So if I go like edit, let's have a look in the root folder here. We've got a README here. But watch if I go edit README dot markdown. It doesn't care that it's the wrong case. Oh, it does. Oh, it does care if I make typos. Here we go. Edit README. There we go. Okay. And I'm just illustrating scrolling here with the scroll wheel on Ubuntu. Double click, selecting something, selecting some text like that. Yeah. Anyway, and then I can go click on my menus here, or I can use the shortcut key file exit. Right, there we go. Okay, cd samples source samples MCU, and you'll see that it's actually in the path here. It's got lowercase for everything because that's what I typed. And if I go edit blink, which I also do as lowercase, when you end up here, you can see it's cased. So it knows this, it uses the case on the system, but it's the environment is case agnostic, doesn't care. Anyway, so we're here and we can press F7 to build, the shortcut for build. So it's F7 to build. There we go. It's pre-processing, compiling, optimizing, generating code. So it's built it. Okay, but we're short of one thing still. We don't have any COM ports. So there's a trick to get COM ports working on Windows. Let's have a look at that. So I have one of these things connected to a COM port already, and it's already running the Blink program, but I'll launch it and run it again. And the easiest way to get this up and running on Windows is there's a little utility in PowerShell I'm going to show you how to use. So the utility we're using is called it's called USB IPD, right? And you have to install it first. It's not here by default. USB IPB. And let me make sure I've got my video on. No, I don't. I'll switch back. So USB IPB. Okay, so figure out how to install that. Just ask ChatGPT, and then if you go list, that's not what we're looking for. I haven't used this much. I'm pretty sure it was that, but let me check quickly. So yeah, that's what happens when you can't really read and don't really understand what the commands are. It's USB IPD, D for dog. So USB IP D for dog. There we go. And then we can do list, and it'll show us those are our USB ports. And the one we're interested in is this COM3 here. It's COM3 on Windows, but there's no such thing as COM ports on Linux. So when we get it working on Linux, it's not necessarily going to be COM3. It's going to be just numbering whatever it finds in order. So the first thing you need to do is you need to attach it to your WSL, your Windows Services for Linux. So it's attach WSL, and you've got to attach using this bus ID here. So it's -- bus ID, and 3-4 is the bus ID, 3-4, right? And that attaches it, and you only have to do this once. It's this will persist for that specific serial device. So for the specific microcontroller, it'll remember that. Unfortunately, every time you launch your Linux box, you have to do a attach. What am I looking at? No, that's correct. You have to bind it once. I've done that before. So I've got these commands the wrong way around. USB ISP ipd bind to bus ID 3-4. It's probably going to say this is already done. Yeah, it's already shared. Yep. So you have to issue this bind instruction once, and that'll persist. But you have to issue the attach instruction every time you run your Linux box. So let's see if it worked. If we go in here and use the port instruction, yes, now suddenly we've got a port, and you can see it's not COM3, it's just whatever COM. Because they have Linux USB names, so it'll show us port port 1 if you've only got one. Okay, so let's switch back to Hopper with video. There we go. So there's obviously that's not great instruction. This is a first look at how to get up and running on Linux via WSL, which is not ideal. What I really need to do is make a video on a Linux box and walk through this again. I've got it working on my Chromebook directly as well. I'll figure out how to video that and document it correctly. Also write text documentation for this so that you don't have to try and figure it out from the video. But let's have a look again, just as a purpose of demo. Let's look at Blink. And now I've already built it, but I'll build it again. I've got it targeting the wrong microcontroller, so I should change that. So let's make that Pico 2W and build it again. And yes, I want to save my changes. Is it Pico 2W or Pico W2? Oh, PyPico. PyPico W. There we go. Yes. And this environment works exactly the same way as the Windows one and looks exactly the same as the Windows one, which is kind of the point because it means all the videos will work the same way. And now we can F5 to launch the debugger, and it's successfully connected to the serial port and uploaded. And you can see the blinking stopped. There's no more blinking here because it's waiting in the debugger. So if I, so it's the same Visual Studio keys, F10, F11, F5, all that. So if I go F10 here, it'll start the debugger, and now we're in the debugger. Set the pin mode, delay, toggle the state of the button of the blinky thing, and you can see like it did. And then on is not on. Wait for half a second. Wait for a second. Come round, and then if we do this, let's change the state here, and then digital write. There we go. So we have blinking when I hit F5, and then if I Control C here, we get to stop on the breakpoint again. So there you have it. Blink working on using. Actually, there's two things happening here. This blink is a little too complicated. It's also blinking a GPI open, not just the LED. The LED is the built-in. And so I can right-click on that and go to the definition, and that's how the built-in LED blink works. And you could right-click and go to the Boolean class, go to the string library. I'm right-clicking to navigate, and then I can double-click here on blink to go back to that one. So mouse functionality working exactly as you'd expect. Scroll wheel, beautiful. The whole environment is, it really works quite well. For a first version, I think it's not bad. So if you were waiting for it to run on Linux before you were going to use it, I'll put a link in the description to get a Discord invite so you can get onto our Discord server. And I'll put text instructions there if there's interest and if people give me feedback. And if you get stuck somewhere, I'll give text instructions as to how to get this up and running on your Linux box, and you can give me some feedback. Anyway, thank you for watching, and please subscribe.